Thank you. 30 years ago, I started a company called, I shouldn't say 30 years, 1980, I started a company called Crow. A lot of people have heard about it, maybe most of you have. But the idea was to make something that was extremely musical, that was hand-built, that people loved the sound of, that was conventionally different than what was on the market at the time. And I did that, and the company became quite successful at doing those things. In 2009, I had a hostile takeover of the company, and they asked me to leave, so I left. And here's me sitting with nothing to do after 30-some years, wondering what I was going to do to make a living, and I decided to start another company. So I started designing another amplifier, and I had this idea, again, to go back to my roots that I did. I started with hand-built stuff, hand-tested. But the difference with this product is I have 30-some years of experience of designing and building products that I was able to put into this design. And that's a significant difference than where I started back in 1980. But I build them the same way, which is why I'm going to that point. These are all hand-built, all the parts are hand-tested. They're built by 4 or 5 people, generally 5 people. Every part in there is used because it sounds good, not because it's a part I can get or because it's cheaper. And I did a lot of things that I was always wanting to do at Crow, but never could get to doing it. And I wasn't shackled to an industrial look that I had already started with. So I couldn't make, I mean, to make this at Crow would have been a total right turn about what products we were making. But to make it as a brand new product without any restrictions was a really, good leap to do. I mean, this is a product of, passion for audio. And when I designed this amplifier, I spent a lot of time designing the circuits and do some things that I always wanted to do, which, for instance, along the way I learned that I could make an amplifier sound just like a Class A amplifier and it not be Class A and give the same things. And I did that with some techniques with the driver stages I use and with the fact that I match my power devices and all the other devices in the audio chain. And that helps doing that. But the circuitry is a big departure from stuff that I did at Crow. It has more distortion. It is quieter, but it has more distortion, but it is more linear. I mean, the distortion at 20 hertz and 20K are almost identical, which is something I never was able to achieve, and very few amplifiers in the market can do that. And then it got to be an industrial design. And when I announced that I was a new company, everybody thought the first thing I was going to do was make a great big amplifier. And that was the furthest thing from my thought path. I wanted to make something really powerful, but I wanted to make something that when you put it in your living room, your wife didn't say, "I'm not living with that." So that was one of my criteria, because I've heard this for 30 years. Wives come in, "Oh, it's beautiful, but you're not putting that in my house," and she'd walk out. And that was a really, and that was the end of anyone thinking about buying one of these and one of my Crows. So, but this is a different thing. When I showed this in the consumer show 2 years ago for the first time, the women that came into the room were just mesmerized by the product. They were touching it, looking at it, and saying, "This is the kind of product I want you to buy." They tell their husband that. He said, "Well, I want to listen to it first." But it was really a complete departure. And I was able to put this kind of performance into a small box by using copper. I was really always wanting to work with it, but I never got a chance to, and then I had a chance to. And with this was really good because copper's got some interesting properties. It absorbs heat, as you know, but it absorbs heat 91% faster than aluminum, which is pretty quick. But it also has a thermal reluctance. I mean, it holds on to heat. It doesn't give off heat like aluminum. But because it has a quick absorption and a high retention, it keeps things in a thermal equilibrium, because that's a huge mass and that's some 30-some pounds of heat sink, each one of those. So once it absorbs the temperature, it stays at the temperature. So it kind of stays at about 42 degrees C. and you could play the hell out of it. It hardly, after 2 hours, it'll hardly even notice a temperature rise. So it's a really solid heatsink. But output devices, like all semiconductors, like to be at the same temperature all the time. Generally, it's pretty warm to our standards. But for them, 42, 46 degrees C is really nothing. And so that was able to do that. So that eliminated my need for great big fins and big heat sinks. And because of the construction I used, I was able to put a lot of power into a very small box. I was fortunate to have a transformer manufacturer 15 minutes from my house. So when I finally got down to getting the power I wanted, I had samples come in from a bunch of other companies, including this guy in Connecticut. So I took the whole chassis over to him, and I drew it out with a magic marker on the inside. I said, this is how much room, and this is how many VA I want, and these are the windings I want. So he looked at it, and I left it with them and let them play around with it. And about 2 days later, he called me up and said, I have a transformer for you. So I brought it home and tested it, and that was it. It's a 1400 VA transformer. It's 9 inches in diameter and about 2 inches tall. It's just a great big pancake. And it works extremely well, but it's very hard to build. So they cost a lot of money, but I said, look, I want it perfect, I want it quiet, and I want this much power. And, you know, a lot of times you can do things, if you don't have to make 100 of them a day, that you couldn't do under high production. So he made a really good product for me. Cost me a lot of money, but and it also takes him a lot of time to build them, because a lot of it's handwork on a very small form. So that's kind of the story. Everything's discrete. It's all bipolar. It's all direct coupled. Got pretty wide bandwidth. There's no real restrictions. It's got very linear distortion, as I said. And so that's kind of the story of the momentum amplifier. And it's been a real interesting thing to do. I did a comparison when I designed it. Of course, now here I am outside of Krell for the first time, but I had every product that I ever made had Krell in my home. So when I did my A/B comparisons with my 5 audiophile friends, we start comparing and comparing. And what I was interested in this is only in the musical part of it. So we just kept on comparing it until we made it sound better than every piece of Krell that I had. And when that was done, I hate to say this, I called a guy up with a big truck, and he came and took it all out of my house and wrote me a check. And all I had was my little Momentums left, which was really nice. And it helped me finance this company. When it came to doing a preamp, I looked at the same approach. Again, everything has to be hand-built. We don't use any wave soldering. There's no surface mount parts. And a preamp's a really difficult thing to do, because if you have an amplifier that sounds good, the last thing you want to do is make it sound worse by putting a preamp in. So consequently, I didn't make a preamp for 2 years, mostly because I was really inundated with trying to get this out on the market and traveling around, and I lost a lot of time doing it, but because I was really curious about how I was going to make it so that it didn't color the sound of the amplifier. So the way I define the coloration of a preamp is I take a really good DAC, I put it all the way up to its maximum volume level to get the digital volume control out. I'd insert resistors in series with it so that the volume level was at a reasonable point, and hook it directly to the amplifier. And then listen to it over a number of different songs and a number of different sample rates. And then put the preamp in between the DAC and the amplifiers. And the idea is that nothing changes. The sound character is exactly the same, except that a preamp has more control, it has better output stages, it gives you better foundation and more space. That's what should happen. But the EQ and the sound of the music should stay exactly the same. And that was really hard to do, because it required that your circuit was an extremely wide linear path. I find that feedback in a preamp it ruins the sound. If you buy a preamp and it's got feedback in it, I don't know everybody's design, but it's been my experience, whenever you apply any feedback, even if it's 3 dBs, it ruins the sound of the preamp. So because it's small signal, and because of the technique I use, I don't have any feedback in it, and there's no nested feedback. It's just a wide open, wide band and there's no compensation in it. So it runs wide band, so it's about a 2 megacycle gain stage, and I use in my input and output the same one. And the distortion is relatively low without feedback. It's 0.005%, generally between 0.005 and 0.08 without feedback, which is a real great accomplishment. But it also is a huge data path for the signal, so there's no deleterious effects by passing the signal through it. So when you get that, when you put the preamp and you insert it, you can't hear that the preamp's in it other than the fact that the sound has more authority and a bigger sound stage. And that's with 2 or 3 $40,000 DACs that I used to compare. And people were nice enough to lend them to me so I could try a number of different flavors. The other thing I did on the preamp was I wanted the industrial design obviously to match the amplifier. But then I started thinking, this is a musical device. And in 1972, you remember this guy, Mark Levinson? He made this really cool line stage preamp, and he left off the tone controls. And you know, he spawned a whole industry of really high-end preamps without tone controls. And he's a guy who lives in Connecticut. So I'm figuring I'm living in Connecticut, and this is 40 years later. I think I could give tone controls back. You know, being from Connecticut and being an audio designer, I think I could give tone controls back to people. And I said, what's wrong with tone controls? The best preamps in the world that we grew up with had tone controls. Marantz 7C, the Macintosh C20, all of them had tone controls. I said, what's wrong with them? And the fact is nothing. There's really nothing wrong with having a tone control. It's just about how you apply it. So I called the governor of Connecticut and I asked him if it was all right if I could put tone controls in my preamp, and he gave me a certificate saying it was all right.